VLSos here. This is a video lesson on solving a system. I have a system of 3 equations, 3 variables. Finding a solution means finding a value for all 3 variables that make all 3 equations true at the same time with the same values. I'm going to use 2 different techniques to find a solution to this system. The first technique I'm going to use is the most common, it's the most reliable. I'm going to rewrite some of these equations in an equivalent form that helps me substitute and get towards finding values for variables. I'm going to take these first 2 equations and I'm going to rewrite them solved for y. The first equation solved for y means I need to subtract x from both sides and then divide by both sides by 2. When I do, I get the equivalent equation y is equal to 4 minus x all divided by 2. The second equation I'll solve for y by subtracting 2x from both sides and then multiplying by -1. When I do, the second equation can be rewritten as y is equal to -7 minus 2x, but then when I multiply by -1, the -7 becomes positive and the minus 2x becomes plus 2x. I have the first 2 equations rewritten. These are equivalent equations. If I find a solution for x and y in these 2 equations, then I will have the same solution for the first 2 equations. How do I proceed now that they're both solved for y? Well, I can substitute what y is equal to in one equation in for y in the other. Or if these 2 expressions are both equal to y, then they're equal to each other. So I can write a new equation. In this case, 4 minus x all divided by 2 is equal to 7 plus 2x. Now I have an equation with one variable, x. I can solve for it and find a value for x. I'm going to undo divided by 2 by multiplying both sides by 2. When I do, I get 4 minus x is equal to 2 times 7 is 14, plus 2 times 2x is 4x. I'm going to subtract 4x from both sides and add subtract 4 from both sides. Let me make a note of that. Minus 4 and then minus 4x. When I do, on the right, I get 4 minus 4 is 10, and a negative x minus 4x is a negative 5x. In the next step, I can get x by itself by dividing by -5. When I do, I get x is equal to -2. I found the value for x. I can immediately substitute this value that I found into one of the equations. This second equation is equivalent to the original second equation. So if I substitute -2 in for x here, I can calculate y. Y will be equal to 7 plus 2 times x. If x is -2, then 2 times -2 is -4, and I get 7 plus 4 is 3, the value of y. Now that I have a value for x and y, I can take those values and substitute them into this original equation that has all 3 variables and solve for my remaining variable z. When I do, I get x, or -2, plus y, which is 3, plus z, still unknown, is equal to -4. To get z by itself, I need to add 2 to both sides and subtract 3. -4 plus 2 is -2. -2 minus 3 is -5. I found my third value. The solution to this system is x, y, and z are -2, 3, -5. This is a typical solution process. It will work. However, there are other strategies for solving systems which could save some time or be easier for some. I'm going to show you a different method by taking by looking at these two equations and noticing that the 2y term and this negative y term are almost equivalent and opposite in sign. If I doubled this second equation, then the 2y and the new negative 2y would be eliminated if I added the equations. Easy to say, hard to understand. So let's see it in action. I can see that I could take advantage of doubling this second equation. I'm going to rewrite it as an equivalent equation, but make a note that I'm going to multiply the entire thing by 2. When I do, I get the equivalent equation 4x minus 2y is equal to negative 14. I doubled this second equation. Why would I do that? Well, I'm going to rewrite the first equation above it. X plus 2y is equal to 4. These two equations are equivalent to the first two equations. So if I find a solution here, I will have found a solution to the original equations. What am I going to do with these to get me to advance me? I'm going to add the entirety of both those equations. When I do, this term, positive 2y, when it's added to negative 2y, will eliminate that term. Y will be eliminated from the new equation. So adding, I'm going to add these and make a note of it. X plus 4x is 5x. Negative 2y minus 2y is 0y, so I won't write it. And 4 plus negative 14 is negative 10. This process gave me a very simple equation to get the value of x. By dividing both sides by 5, I get x is equal to negative 2. I knew that because it's equivalent to my first process, but I arrived at it in a different way. Now that I have a value for x, I'm going to use another strategy. I'm going to take these two equations, the original second and third, and by the same reasoning, if I add these two equations, because the y term is equivalent but opposite in sign, they will eliminate. These two equations added together will form the equivalent equation. 2x plus x is 3x. Negative y plus y is 0, so I'm not going to write it. And 0 plus z is equal to negative 7, and negative 4 is negative 13. But I have a value for x. So if I substitute negative 2 in for x immediately here, then I will get a 3 times negative 2, or negative 6, plus z is equal to negative 13. And to get z by itself, I add 6 to both sides. I made a mistake earlier, which I caught and I'm going to clean up. Negative 7 and negative 4 do not combine to be negative 13, they're negative 11. So after correcting for that, and adding 6 to both sides, I get negative 11 plus 6 is negative 5. Z is equal to negative 5, which has been previously calculated. I still need to get y. I have a value for x and z. I could go back to any equation that includes y in it. In this case, if I take my value of x, negative 2, and I add 2y is equal to 4, and I add 2 to both sides, and then divide both sides by 2 to get y by itself, I get y equals 3. These strategies are different in that I combined equations to eliminate terms in the second strategy, and here I solve for variables and then set them equal to each other. Both strategies included finding equivalent equations to help the solution process in eliminating variables and getting values.